Okay, now remember, he asked, do you want us to put it in radians or keep it in degrees? It depends on what the angle is you're talking about. So if I am doing a degree problem, I will want degrees. I will have to have the mode in degrees. If I'm doing a radian looking value, you have to have it in radians. Okay, and remember, the answer you get is neither. Because what is the answer you get representing?
A ratio.
Nice. I never hear that loud in a response. There's only half of you here. Yes, the trig function of any angle is a ratio. So these weird decimals that they're spitting out, or whatever you get spit out, those are ratios of the two sides of the triangle that has that angle. And I know when you look at 136, you're like, what right triangle has an angle of 136? Well, you're right, there isn't one. But if I move it over, that 136 does make a right triangle, right, with the x-axis. And the reference angle there is kind of what we're dealing with. But the great thing is your calculator will figure all that junk out. So I just want to walk you through how to use these initially. And crud, I cannot show my calculator. I tell you what, if you have a scientific, first thing, just do a scientific. Does anybody have a scientific? Okay, so I want you, do y'all know how to change to radians,
Yes.
in degrees? You do not?
Okay.
Yeah, there's a DRG right there that you can see switches, and you just go, like the first one's degrees, so you're going to want degrees. All right, and you'll see deg at the bottom.
Okay.
Is everybody good? Anybody else? We're all good, okay. Yeah, if it says deg, your degrees. And rad would be radians. If it says grad, that's a gradient measure, which is like 100 as opposed to 90 would be a right angle. We don't ever use grad in anything that I've ever seen in college. I'm sure there is a use for it if it's on there, but I've never used it once, ever. I had to look up what it was. Anyway, so type in tangent of 43, and you should get what? If you're in the correct mode, which I am not, degree. You can only imagine how bad it is for you when you don't do that. But when you type that in, you get 0.9. We're going to round to 3 decimal places. So 0.933. So 0.9933. So the ratio is almost 1. So for tangent, that means the opposite and the adjacent have almost a ratio of 1. So, but it's a little bit small. Sine of 136 shouldn't be a big deal, right? Type that in there. 0.695, rounded to 3 decimal places. Now, what about that? First of all, that is not a degree measure, is it? You see a pi, that's already, bottom line is you don't see the little degree bubble. So even if that was something like, 5.72, you would have to go, well, there's no degree bubble, it must be radians. It's the degree bubble that lets you know. Remember, pi is just a number. It's 3.1415926, blah, blah, blah. So if I were to multiply that out, I'd get some decimal. You can tell it's a degree if it has a bubble. If it doesn't have a bubble, you have to assume radian. All right? I'm not going to be dirty and put cosine of 135 and leave the bubble off and go, ha! Just because it looks like a kind of degree, we can. If it doesn't have a bubble, it's not. If I'm going to leave a bubble off, it'll either have a pi on it, like that, or it will have a weird decimal that this looks odd. It's kind of a red flag. Good. Okay, so here's what we have to do here. I've got to go cosine, and then I've got to make a fraction, or go 7 pi divided by 12. So if you want to make a fraction, there's a fraction button on there. If you have a scientific, it's probably not easier to do that. I would type in cosine 7 times pi divided by 12. I would do that. Either way, what happens, and I got to remember to change my mode, change to radians, and go cosine of 7 pi divided by 12, and you get negative 0.259. Does everybody get that? Okay, if you didn't get that, did you close parentheses after the 12? Are you sure you're in rad mode, radian mode?
Do you have to swap to radian?
If it's a radian, you got to be in radian. You will not get it.
Mine wasn't working for the first two, but I switched it to degrees.
It should work if it's in degrees for these, but not for that. Guys, you've got to be in the right mode. Is anybody struggling right this second? Raise your hand. Yes.
How do I put it in the rating? Wait,
You hit the mode button,
okay, never mind.
then you use your arrows.
Are you guys on the Inspire? I'm going to go to that in a second, but are you okay on the Inspire? Did you figure it out? You did? Okay. Now, real quickly on the Inspire. The Inspire is great, and I would switch this screen, but I'm going to lose this, and I don't want to lose this up here right now. The Inspire has a little trig button, and when you hit that trig button, you got to be on your calculate mode. But if you hit that little trig button, you have all 6 trig functions, which you're going to see is awesome, because in a second, when I get to these, it becomes much harder. Not much. It becomes somewhat harder on a scientific than it is here. Okay. But on this one, at the top right of your screen, it'll say rad or deg. All right. So if you have a newer one that has a white face like you have, if you just go, if you're on this screen and you're doing calculations, if you go menu, I'm sorry. No, it doesn't do that on these new ones. Yeah, you got to go up to the rad and click on it. It changes depending on the calculator. If you take your little cursor and swing the little hand up there and click on rad, it changes it to deg. Y'all seeing that? Okay. But anyway, you also have a nice fraction button on this. It's right above your division sign. So you can put a fraction in there and type in 7 pi over 12. And if you're wondering where pi is down there on the bottom left. Y'all with me on that if you have an Inspire? Okay. Anybody? Crenshaw, you good? Okay. So tangent of 3 pi over 5. Have you all done that? You should get negative 3.078. And again, I'm rounding to 3 decimals. You all with me? Okay, so here's what becomes trickier for you guys with scientifics. And it'll become increasingly tricky as we move through the day. So it's not impossible. We did it for a zillion years without it before the Inspires. I did it for 20-something years. But with the Inspire, it's going to make your life so much easier. And if you're going to have one, order one today. It'll be here probably by Monday. And then you'll be able to take this test and it'll be easier on you. All right? So here's what you have to do. Everybody who doesn't have an Inspire does not have a cotangent button. So what you have to do is think, well, what do I know about cotangent? Cotangent of an angle is the same as 1 over tangent of the angle, right? Do not confuse that with, it is not equal to the tangent of reciprocal of the angle. That is not right, okay? You can, though, say that this is the same thing as 1 over the tangent of 110. Now I'm going to have to go back to degrees, but if I do that, it will spit out the correct value. And you're like, well, that's not that hard. You're right, it's not, but it's so much easier in the future when I'm dealing with cotangent to just go cotangent 110, done. Yes.
What if it says cosine to
The negative 1 is inverse. That is totally different. That's what we do when we're solving for an angle. So do not use cosine negative 1. I know that's good thinking in the sense that you're used to negative 1 meaning reciprocal. It does not mean reciprocal in this case. Okay? So I'm glad he asked that question. I forgot to address that. But do not use inverse cosine, inverse sine, or inverse tangent to try to do cotangent, secant, cosecant. It is not going to work. All right? So avoid those for now, although we will get to those today. Okay? That's what we do when we're solving an equation, and you'll see in a second. So right here, if I type that into my calculator, cotangent of 110, actually I have it. Yeah, I have. I get negative 0.364. Everybody get that?
Yes.
If everybody got that, great. Right here, if you have an Inspire, you can just type in secant of 312. If you don't, what are you going to have to do? What is secant a reciprocal of? Cosine. So you go 1 over the cosine of 312. And when you type that in, you should get 1.495 if you're rounding to 3 decimal places. Well, actually, mine says 0.4945, but what is it?
0.4944.
0.4944. So I had already rounded to the 5. So that ends up being a 4 right there. If you're rounding to that. And then the last one I have, not the last one, I have cosecant of 103. What is cosecant a reciprocal of? Sine. So I am thinking in my head 1 over sine, or I'm typing in my calculator 1 over sine of 103. And I do that and I get 1.0263. Now the last one. Yes.
So what are we rounding to? Is it just 3?
Just depends on what the problem will ask you. Oh yeah, no, sorry. Yeah, I've been rounding to 3. All right, so, but that will vary from problem to problem. Your book will say different things. The last one I threw up a cotangent. Every year I have people go, oh, cotangent. Now, if you have an Inspire, it's easy, right? Hit the cotangent button, make a little fraction, 16 pi over 13, but it is a radian, right? So I got to switch back to radian mode first, or whatever. And then I'm going to have to type in this 1 over tangent of 16 pi over 3. But guys, burn this in your brain. You have nothing, never a reason to take a reciprocal of an angle. I never once took my angle and flipped it, did I? The angle never got flipped. The trig function, I took the reciprocal of it, but I never took the reciprocal of an angle. So you have never a reason to take 16 pi over 13 and write 13 over 16 pi. If you find yourself literally flipping the angle, you're doing something wrong. Okay? I mean, I've never seen an application where you take a reciprocal of an angle unless somebody goes, hey, take a reciprocal of an angle. But I mean, I'm not doing that. So, and that would have spit out what?
1.129.
1.129 is what I got.
It's over 13, not
Oh,
over 3.
yeah.
That's why I did.
My bad. 1.129. Are y'all seeing this? Shockingly, most missed things on the test. I got in the wrong mode. I flipped the angle. I don't know how to take a reciprocal. But guys, if you have an Inspire, you are literally typing this junk in. Oh, another thing about the Inspire I want to mention to you. Click on, if you have an Inspire, click on the pi button. What do you see when you click on that pi button other than pi? Down at the bottom. You see a little degree sign, right? And what's next to the next to the degree sign? An R. That means degrees and radians. So let's just say you were in degree mode and you're like, oh, I don't want to change the mode again. You could just go there and right after your, like if I was in degree mode, right after typing this in, I could put a little R. Can you see that? Like if this is right here. Now you got to be careful about it. Like really careful. Like say this is my trig function right here. You could come outside this fraction and put a little R. And it will tell the calculator, oh, I'm in degree mode. Same thing. Let's just say you were in radian mode, right? And I'm typing this in my calculator. If I'm typing, and you wouldn't have that, but like right here, say it was in radian mode and you didn't want to change modes, but you wanted it to be a degree for just that problem, you can put the little degree in there and your calculator will go, oh, it's a degree. Now, I normally just change the mode, and 95% of what we do, if not more, on this test will be in degree mode. So if it were me, I'd keep it in degree mode, maybe knock out the couple problems like this that are radians, and then the rest of the work will be done in degree mode. Are y'all with me? Okay, so here's the next thing we need to learn how to do. The next thing we need to learn how to do is solve simple trig equations. So we're going to be solving. You were not just solving before, you were just simplifying. There were no variables you were trying to figure out, right? So this will be an equation, and I'm asking you the sine of what angle, if I'm putting a variable in there, will give me this ratio. So that 0.524 evidently represents some hypotenuse, some opposite over some hypotenuse, right? But I don't know what angle would have given me that. If it was a 0.5, I would, because where is sine a half? What angle gives me sine of a half? 30 on the unit circle, and also 150. We'll get to that later. But right here, I have no idea. Now, the fact that it's a little bit bigger than a half tells me it's around 30. but I don't know exactly. So here's how I'm going to solve. Now, this first step, you don't need to write, but I wanted to show you the thinking of it. Do you know that when I have a function, if I take the inverse function of a function, they cancel? Okay, so technically, and this is where the inverse comes in. If I inverse sine the left side, and don't write that, well, you can if you want, but I will never write this again. And I inverse sine the right side, if I do that, and you'll see me doing it right here. Okay, the inverse sine and the sine cancel, leaving me this. Okay, now I skip this row. I just go, oh. In fact, I even sometimes find myself saying, oh yeah, if you got a sine on this side, move it to the other side, make it an inverse sine. I'm really not moving it. I'm inverse sining both sides. That cancels and I get a theta. Okay, now, sadly, we don't talk a lot about inverse sine in this class. We don't. The inverse sine function is a different function than the sine curve. The sine curve wiggles forever along the x-axis, okay? The inverse sine curve, in theory, would wiggle along the y-axis. There's only one problem. If I wiggle up and down the y-axis, it doesn't pass the vertical line test. So the creators of the inverse function said, well, we want it to be an actual function. So what if instead, and this is kind of what it would, let me think for 1 second. It would kind of look like this. But this clearly doesn't pass the vertical. So for the inverse sine, you don't have to remember any of this right now. For the inverse sine function, they chopped it right there and right there. And they only kept this part. Okay, now that just happens to be between 90 and negative 90 degrees. What you just need to remember is that if you ever type this in your calculator physically cannot give you an answer that's outside negative 90 to 90. Can't do it. But the problem is, I didn't start you with this. I started you with this. And that's the inverse sine. The sine function has an infinite number of angles that have a height of 0.5, up 0.5, up 0.5, up 0.5, up 0.5, up 0.5, up 0.5. So what I do is I use this to help me get an angle, and then I use my brain to find all the other ones. So we're going to type this in our calculator, but here's the trick. This is going to spit out not theta, it's going to spit out the reference angle of theta. And we talked about reference angles, didn't we? So I am going to type inverse sine of that. And by the way, if you're still in radian mode, go to degrees, because we're going to work all these problems in degree mode. It's easier to think. So take your calculator out and go second sine, which is inverse sine of 0.524. And when you do that, it should spit out, I am in the wrong mode. It spits out 31, and we're going to round just to the tenths. Did everybody get 31.6 degrees? Now, by the way, to ensure that it's a reference angle, if this right here were negative, we always make it positive. Always. That makes it a reference angle, and you're going to like that. And we'll talk about it later. So here's now how you have to think. Okay, where would sine have positive ratios? Where would that occur? Now think about it. Think about your unit circle. What does sine use? Opposite and the hypotenuse, right? And your hypotenuse is always positive because it's a length. But your adjacent sometimes is negative, sometimes positive. And your height, that's sometimes positive or negative. If sine is always y over r, right? And the r is always positive, that would mean that if this is positive, it would have to be in which two quadrants? First and second. Do y'all see that? Now I'm going to give you a shortcut way to know that. It's a little thing. This is where are the trig functions positive? All of them are positive here. That should make sense. Why? Because the x, the y, and the r are all positive. Right? Here, the y is positive, but the x is negative. R is still positive. So here, which ones are going to be positive? Only those that use y and r, which are sine and also cosecant, because that's a reciprocal. Here, what did you find out? The x and the y are negative, right? So which ones end up being positive here? Tangent, because tangent uses y's and x's, and the negatives cancel, right? So tangent is going to be positive here as well as cotangent. Y'all see that? But all the ones that just use one r, like y over r, x over r, whatever, all the other ones, they got a negative. So those are not where they're positive. And then lastly, right here, which ones here would be positive? X and r, cosine, and its reciprocal. Now which is secant. Now let me show you a little dumb way to memorize this. All students take calculus. At least all good students, or all students take classes. All of the trig functions are positive there. Sine and its reciprocal. Tangent and its reciprocal. C, cosine and its reciprocal. That's where they are positive. So what you have to do here is say, where is sine positive? Well, where is sine positive? They're all positive here, right? And sine is positive here. And if my reference angle is 31.6, let me write the reference angle. Remember, that's the angle formed by that and the x-axis. So if that's a 31.6 and that's a 31.6, can you tell me what the real angles are? What are the actual angles? Well, the first one is the angle, right? 31.6. We're going to do this a bunch. You'll see it. And then what's the other one? 180 minus that 31.6. Does that make sense? Because if that part's 31, and I always measure angles from 0, that would be 180 minus 31, so 148.4. We're going to do this a couple times so you see. So once again, right here, you can ignore that step, but you make the inverse sign of the other side. And so that I will get the reference angle, what do I always do to this decimal? Make it positive. That will give me the reference angle. Then I have to decide, where do I put the reference angle? Go back to the problem and go, where is sine positive? Sine is positive first and second quadrant. So draw a little angle in the first and the second, put the reference angle there and there, and then figure out what the real angles are. Are y'all seeing this? And these are where your angles exist from 0 to 360. But guess what? What if I didn't limit you to one revolution? How do I find all the other coterminal angles? So she said add 360. So the way to really write this is to say plus 360n. And people will know that n means an integer, which means I could add 360 or subtract 360 to this any number of times, and it would still make this equation true. But my guess is on this homework for you guys, on this homework, you're probably going to get a whole lot of this. Find the angles between 0 and 360 that work. So if all I care about are the angles within one revolution, I don't care about all these other ones. But if I did not have that in red, if it's not included, you would have to write plus 360n to both of those. But in this case, if I put that there, you don't have to. Does that kind of make sense? Let's try it, run through it again. So what if I gave you this? What if I gave you, try something different. Cosine of an angle equals negative 0.8246. And again, the question would be to solve. And I'm going to go ahead and tell you the angle is it's going to be between 0 and 360. So all I have to do are find the couple of angles that exist there. So what's our first step? We're technically inverse cosigning both sides, but that will jump me right to here, won't it? And when I do that, what do I want to do with this negative? Make it positive. And why do I want to do that? Because that will make this spit out what? The reference angle, which is what I need to have, right? So I type this in my calculator, and it spits out 34.5 degrees. So my reference angle, not my answer, is 34.5. By the way, on the last problem, the reference angle was one of your answers, but you're going to see on this one it won't be. So now I got to ask myself, where would this reference angle show up? So where is cosine negative? Well, tell me, where does cosine, where is it negative based on our all students take classes? First and fourth, because they're all, sorry, where is cosine negative? Not first and fourth, what?
Second and third.
Second and third, because it's positive here and here, right? Cosine's positive there and there, which makes it negative here and here. Are y'all with me on that? Okay, so I take this little reference angle and I shove it in here, 34.5, 34.5. Now, that's not what I want. I want the real angle that's measured from what? From 0, from standard position. Good. I want those two angles. So what is that one right there? 180 minus the 34.5. So what? 145.5.
The other's 180 plus.
And the other one's going to be 180 plus the 34.5. And if you need to write that in there, write it in there. And that gives me 214.5. Y'all seeing that? Now, sadly, we did not get to how to deal with the cosecant, secant, cotangent. So on your homework, if there's a cosecant, now if you have a Inspire, it is no different. But if you don't have an Inspire, it is different. And I'll have to talk about that tomorrow. So if you want to skip those few problems, you can.
Are they the 1.5 and 11? Or are they?
I couldn't tell you off the top of my head. All right. You have a good one. Yeah, man.